My dear students, hello. I welcome you all in our series of lectures on cybersecurity. Today, we are going to learn about database security. So, let us begin with it. Database security is a very broad area that addresses many issues, including number 1, legal and ethical issues regarding the right to access certain information, because some information may be deemed to be private and cannot be accessed legally by unauthorized persons. Number 2, policy issues at the governmental, institutional or corporate level as to what kinds of information should not be made publicly available, for example, credit ratings and personal medical records. Number 3, system related issues such as the system levels at which various security functions should be enforced. For example, whether a security function should be handled at the physical hardware level, the operating system level or the DBMS level. Number 4, the need in some organizations to identify multiple security levels and to categorize the data and users based on these classifications. For example, top secret, secret, confidential and unclassified. The secret policy of the organization with respect to permitting access to various classifications of data must be enforced. Now, what are the various threats to databases? Threats to databases result in the loss or degradation of some or all of the security goals, such as integrity, availability and confidentiality. Loss of integrity refers to the requirement that information be protected from improper modification. Modification of data includes creation, insertion, modification, changing the status of data and deletion. Integrity is lost if unauthorized changes are made to the data by either intentional or accidental acts. If the loss of system or data integrity is not corrected, continued use of the contaminated system or corrupted data could result in inaccuracy, fraud or erroneous decisions. Loss of availability refers to making objects available to a human user or a program to which they have a legitimate right. Loss of confidentiality refers to the protection of data from unauthorized disclosure. The impact of unauthorized disclosure of confidential information can range from violation of the Data Privacy Act to the jeopardization of national security. Unauthorized, unanticipated or unintentional disclosure could result in loss of public confidence, embarrassment or legal action against the organization. To protect databases against these types of threats, 4 kinds of countermeasures can be implemented: access control, inference control, flow control and encryption. In a multi-user database system, the DBMS must provide techniques to enable certain users or user groups to access selected portions of a database without gaining access to the rest of the database. This is particularly important when a large integrated database is to be used by many different users within the same organization. For example, sensitive information such as employee salaries or performance reviews should be kept confidential from most of the database system's users. A DBMS typically includes a database security and authorization subsystem that is responsible for ensuring the security of portions of a database against unauthorized access. It is now customary to refer to 2 types of database security mechanisms. Those are: number 1, discretionary security mechanisms. Discretionary security mechanisms are used to grant privileges to users, including the capability to access specific data files, records or fields in a specified mode, such as read, insert, delete or update. Number 2, mandatory security mechanisms. Mandatory security mechanisms are used to enforce multi-level security by classifying the data and users into various security classes or levels and then implementing the appropriate security policy of the organization. For example, a typical security policy is to permit users at a certain classification level to see only the data items classified at the user's own classification level. An extension of this is role based security, which enforces policies and privileges based on the concept of roles. A second security problem common to all computer systems is that of preventing unauthorized persons from accessing the system itself, either to obtain information or to make malicious changes in a portion of the database. The security mechanism of a DBMS must include provisions for restricting access to the database system as a whole. This function is called access control and is handled by creating user accounts and passwords to control the login process by the DBMS. A third security problem associated with databases is that of controlling the access to a statistical database, which is used to provide statistical information or summaries of values based on various criteria. For example, a database for population statistics may provide statistics based on age groups, income levels, size of household, education levels and other criteria. Statistical database users such as governmental statisticians or market research firms are allowed to access the database to retrieve statistical information about a population, but not to access the detailed confidential information on specific individuals. Security for statistical databases must ensure that information on individuals cannot be accessed. It is sometimes possible to deduce or infer certain facts concerning individuals from queries that involve only summary statistics on groups. Consequently, this must not be permitted either. This problem is called statistical database security. The corresponding countermeasures are called inference control measures. Another security issue is that of flow control, which prevents information from flowing in such a way that it reaches unauthorized users. A final security issue is data encryption, which is used to protect sensitive data such as credit card numbers that is being transmitted via some type of communications network. Encryption can be used to provide additional protection for sensitive portions of a database as well. The data is encoded using some coding algorithm. An unauthorized user who accesses encoded data will have difficulty deciphering it, but authorized users are given decoding or decrypting algorithms or keys to decipher the data. Encrypting techniques that are very difficult to decode without a key have been developed for military applications. Next is database security and the DBA. The database administrator is the central authority for managing a database system. The DBA's responsibilities include granting privileges to the users who need to use the system and classifying users and data in accordance with the policy of the organization. The DBA has a DBA account in the DBMS, sometimes called a system or super user account, which provides powerful capabilities that are not made available to regular database accounts and users. DBA privileged commands include commands for granting and revoking privileges to individual accounts, users or user groups, and for performing certain types of actions such as number 1, account creation. This action creates a new account and a password for a user or a group of users to enable access to the DBMS. Number 2, privilege granting. This action permits the DBA to grant certain privileges to certain accounts. Number 3, privilege revocation. This action permits the DBA to revoke or cancel certain privileges that were previously given to certain accounts. Number 4, security level assignment. This action consists of assigning user accounts to the appropriate security classification level. The DBA is responsible for the overall security of the database system. Account creation, as discussed before, is used to control access to the DBMS as a whole, whereas privilege granting and revoking are used to control discretionary database authorization, and security level assignment is used to control mandatory authorization. Then comes access protection, user accounts and database accounts. Whenever a person or a group of persons need to access a database system, the individual or group must first apply for a user account. The DBA will then create a new account number and password for the user if there is a legitimate need to access the database. The user must log in to the DBMS by entering the account number and password whenever database access is needed. The DBMS checks that the account number and password are valid. If they are, the user is permitted to use the DBMS and to access the database. Application programs can also be considered as users and can be required to supply passwords. It is straightforward to keep track of database users and their accounts and passwords by creating an encrypted table or a file with the two fields, account number and password. This table can easily be maintained by the DBMS. Whenever a new account is created, a new record is inserted into the table. When an account is cancelled, the corresponding record must be deleted from the table. The database system must also keep track of all operations on the database that are applied by a certain user throughout each login session, which consists of the sequence of database interactions that a user performs from the time of logging into the time of logging off. When a user logs in, the DBMS can record the user's account number and associate it with the terminal from which the user logged in. All operations applied from that terminal are attributed to the user's account until the user logs off. It is particularly important to keep track of update operations that are applied to the database, so that if the database is tampered with, the DBA can find out which user did the tampering. To keep a record of all updates applied to the database and of the particular user who applied each update, we can modify the system log. The system log includes an entry for each operation applied to the database that may be required for recovery from a transaction failure or system crash. We can expand the log entries so that they also include the account number of the user and the online terminal to that applied each operation recorded in the log. If any tampering with the database is suspected, a database audit is performed, which consists of reviewing the log to examine all accesses and operations applied to the database during a certain time period. When an illegal or unauthorized operation is found, the DBA can determine the account number used to perform this operation. Database audits are particularly important for sensitive databases that are updated by many transactions and users, such as a banking database that is updated by many bank tellers. A database log that is used mainly for security purposes is sometimes called an audit trail. Next is discretionary access control based on granting and revoking privileges. The typical method of enforcing discretionary access control in a database system is based on the granting and revoking of privileges. Let us consider privileges in the context of a relational DBMS. In particular, we will discuss a system of privileges somewhat similar to the one originally developed for the SQL2 language. Many current relational DBMS use some variation of this technique. The main idea is to include statements in the query language that allow the DBA and selected users to grant and revoke privileges. Let us discuss various types of discretionary privileges. In SQL2, the concept of an authorization identifier is used to refer, roughly speaking, to a user account or group of user accounts. For simplicity, we can use the words user or account interchangeably in place of authorization identifier. The DBMS must provide selective access to each relation in the database based on specific accounts. Operations may also be controlled. Thus, having an account does not necessarily entitle the account holder to all the functionality provided by the DBMS. Informally, there are two levels for assigning privileges to the use of the database system. Number 1, the account level. At this level, the DBA specifies the particular privileges that each account holds independently of the relations in the database. Number 2, the relation or table level. At this level, the DBA can control the privilege to access each individual relation or view in the database. The privileges at the account level apply to the capabilities provided to the account and can include the create schema or create table privilege to create a schema or base relation, the create view privilege, the alter privilege to apply schema changes such as adding or removing attributes from the relations, the drop privilege to delete relations or views, the modify privilege to insert, delete or update tuples, and the select privilege to retrieve information from the database by using a select query. Notice that these account privileges apply to the account in general. If a certain account does not have the create table privilege, no relations can be created from that account. Account level privileges are not defined as part of SQL2. They are left to the DBMS implementers to define. In earlier versions of SQL2, a create tab privilege existed to give an account the privilege to create tables. The second level of privileges applies to the relation level, whether they are base relations or virtual relations. These privileges are defined for SQL2. Privileges at the relation level specify for each user the individual relations on which each type of command can be applied. Some privileges also refer to individual columns of relations. SQL2 commands provide privileges at the relation and attribute level only. Although this is quite general, it makes it difficult to create accounts with limited privileges. The granting and revoking of privileges generally follow an authorization model for discretionary privileges known as the access matrix model, where the rows of a matrix M represent subjects, users, accounts or programs, and the columns represents objects such as relations, records, columns, views or operations. Each position Mij in the matrix represents the types of privileges such as read, write, update that subject I holds on object J. To control the granting and revoking of relation privileges, each relation R in a database is assigned an owner account, which is typically the account that was used when relation was created in the first place. The owner of a relation is given all privileges on that relation. In SQL2, the DBA can assign an owner to a whole schema by creating the schema and associating the appropriate authorization identifier with that schema using the create schema command. The owner account holder can pass privileges on any of the owned relations to other users by granting privileges to their accounts. In SQL, various privileges can be granted on each individual relation R, such as number 1, select privilege on R. It gives the account retrieval privilege. In SQL, this gives the account the privilege to use the select statement to retrieve tuples from R. Number 2, modify privileges on R. It gives the account the capability to modify tuples of R. In SQL, this privilege is further divided into update, delete and insert privileges to apply the corresponding SQL command to R. In addition, both the insert and update privileges can specify that only certain attributes of R can be updated by the account. Number 3, references privilege on R. It gives the account the capability to reference relation R when specifying integrity constraints. This privilege can also be restricted to specific attributes of R. Notice that to create a view, the account must have select privilege on all relations involved in the view definition. Next is specifying privileges using views. The mechanism of views is an important discretionary authorization mechanism in its own right. For example, if the owner A of relation R wants another account B to be able to retrieve only some fields of R, then A can create a view V of R that includes only those attributes and then grant select on V to B. The same applies to limiting B to retrieving only certain tuples of R. A view Vi can be created by defining the view by means of a query that selects only those tuples from R that A wants to allow B to access. Then comes how to revoke privileges. In some cases, it is desirable to grant a privilege to a user temporarily. For example, the owner of a relation may want to grant the select privilege to a user for a specific task and then revoke that privilege once the task is completed. Hence, a mechanism for revoking privileges is needed. In SQL, a revoke command is included for the purpose of cancelling privileges. Now, next is propagation of privileges using the grant option. Whenever the owner A of a relation R grants a privilege on R to another account B, the privilege can be given to B with or without the grant option. If the grant option is given, this means that B can also grant that privilege on R to another accounts. Suppose that B is given the grant option by A and that B then grants the privilege on R to a third account C also with grant option. In this way, privileges on R can propagate to other accounts without the knowledge of the owner of R. If the owner account A now revokes the privilege granted to B, all the privileges that B propagated based on that privilege should automatically be revoked by the system. It is possible for a user to receive a certain privilege from 2 or more sources. For example, A4 may receive a certain update R privilege from both A2 and A3. In such a case, if A2 revokes this privilege from A4, A4 will still continue to have the privilege by virtue of having been granted it from A3. If A3 later revokes the privilege from A4, A4 totally loses the privilege. Hence, a DBMS that allows propagation of privileges must keep track of how all privileges were granted, so that revoking of privileges can be done correctly and completely. Let us understand it with the help of an example. Suppose that the DBA creates 4 accounts A1, A2, A3 and A4 and wants only A1 to be able to create base relations. Then the DBA must issue the grant command in SQL like grant create tab to A1. The create tab privilege gives account A1 the capability to create new database tables and hence an account privilege. This privilege was part of earlier versions of SQL, but is now left to each individual system implementation to define. In SQL 2, the same effect can be accomplished by having the DBA issue a create schema command like create schema example authorization A1. Now, user account A1 can create tables. To continue our example, suppose that A1 creates 2 base tables employee and department as shown in the figure. A1 is then the owner of those 2 relations and hence all the relation privileges on each of them. Next, suppose that account A1 wants to grant to account A2 the privilege to insert and delete tuples in both of these relations. However, A1 does not want A2 to be able to propagate these privileges to additional accounts. A1 can issue the command grant insert delete on employee department to A2. Next is specifying limits on propagation of privileges. Techniques to limit the propagation of privileges have been developed, although they have not yet been implemented in most DBMS and are not a part of SQL. Limiting horizontal propagation to an integer number I means that an account B, given the grant option, can grant the privilege to at most I other accounts. Vertical propagation is more complicated. It limits the depth of the granting of privileges. Granting a privilege with a vertical propagation of 0 is equivalent to granting the privilege with no grant option. If account A grants a privilege to account B with a vertical propagation set to an integer number j greater than 0, this means that the account B has the grant option on that privilege, but B can grant the privilege to other accounts only with a vertical propagation less than j. So, in effect, vertical propagation limits the sequence of grant options that can be given from one account to the next based on a single original grant of the privilege. With this, our today's lecture is over. Finally, let us quickly conclude what we have learned today. We learned what is database security, various threats to databases, role of database administrator. Besides, we also learned about various access control mechanisms. I hope you have understood what we have learned today. In the next class, we shall learn about mandatory and role based access control and related concepts. Till then, goodbye, have a nice day.